Good morning, students. Today we'll start the chapter name is motion. Okay, we are entering into the physics syllabus of class 9 and we are starting with the chapter motion. Okay, before starting the chapter, first let's understand what is the meaning of motion. What is the exact meaning of motion? Okay, what is motion? Motion means if an object, if object moves with respect to the time, if object changes position with respect to the time, then that concept is known as motion. Okay, when any object changes its position with respect to time, then that phenomena or that concept is known as motion. Okay, when any object changes its position with respect to the time, then that phenomena is known as motion. Okay, now motion is a relative term. What is the meaning of relative? If I say any object change its position with respect to the time, now object change its position with respect to whom? With respect to time. So if any object changes its position with respect to time, then that is known as motion. Therefore motion is a relative term, because when object changes position with respect to time, okay, it depends on time. Object changes its position with respect to time, therefore motion is a relative term. We can say motion is relative term. Okay, motion is relative term. Okay, for example, if I say I am going to 20 kilometer, okay, I am going to the 20 kilometer with respect to what? With respect to my house. For example, I am traveling 20 kilometer, okay, with respect to my house. Okay, therefore the traveling of mine is depends upon with respect to my house. Okay, therefore my traveling is a relative term with respect to house, because I have traveled 20 kilometer from my house. So motion is a relative term because it depends upon the time. Therefore its definition is when any object changes its position with respect to time, then that concept is known as motion. Therefore we have called the motion is a relative term. Clear? Then now we'll discuss some basic factors in the chapter motion, and among these basic factors, first factor is position. Okay, first factor is position. Position. The definition of position is the location of any object. Position is the location of any object. Okay, with respect to any point. Position, okay, position is the location of any object with respect to any point, and that point is known as origin or reference point. Okay, position. What is the meaning of position, or what we can write? The definition of position is the location of any object. Okay, position is the location of any object with origin or reference point. Okay, position is the location of any object. Okay, position is the location of any object with respect to any point. For example, we can understand the meaning of position by the example. For example, this is school and my house. Okay, if I say my school is 2 kilometers away. Okay, if I say my school is 2 kilometers away, then this information is sufficient to understand my school is 2 kilometers away. Then the question will be from where. Okay, if I say my school is 2 kilometers away, then the first question arises in our mind, from where? From where my school is 2 kilometers away? So if I say my school is 2 kilometers away from my house, okay, from my house, then this house is known as origin. This house is known as origin. Okay, so the position of any object with respect to any point. Okay, position. Position, what is position? Is the location of any object with respect to any point, and that point is known as the origin, is known as the position. For example, if I say my school is 20 kilometers away, my school is 20 kilometers away, my school is 20 kilometers away. From where? From my office. From my office. Then what is this office is known as? Office is origin. Okay, the position of any object or the location of any object with respect to a particular point, then that concept is known as the position. Clear? So these 2 points are the origin. If I say my school is 2 kilometers away, from where? From my house. So house will be origin. If my school is 20 kilometers away, from where? From my office, then this point is known as the origin. This point is known as origin. Clear? Okay. The next concept is there are 2 quantities in physics. First is scalar quantity and second is vector quantity. These 2 quantity we are going to study in this chapter. First is scalar quantity and second is vector quantity. Okay, so scalar quantity. Second term is scalar quantity. Okay, what is scalar quantity? When any object is denoted only with the help of number, or we can say if any object is denoted with the help of magnitude. If any object is denoted with the help of magnitude, then that quantity is known as scalar quantity. Then that quantity is known as scalar quantity. So we can say when any quantity is denoted by magnitude. And what is the meaning of magnitude? We can say number. When any quantity is denoted by magnitude, okay, then that concept is known as scalar quantity. That quantity is known as scalar quantity. Okay, magnitude means number. For example, 20 kilometer, 2 centimeter, 5 kilometer, okay, 100 meter. So we are denoting only the numbers, and that number is known as magnitude. For example, we can say mass. Okay, we can say volume. Okay, volume. For example, I have 2 liters of milk. I have 2 liters of milk. Then I am denoting the volume only by 2 liters. That means I am denoting it only with the help of magnitude. Magnitude means number. Okay. Speed. Speed is denoted by number only. speed of my car is 20 km per hour, or I can say I am driving my motorbike at 60 km per hour. Okay, so I am using only number to denote the quantity. Okay, to denote the speed I am using only number. Speed 20 km, volume 2 liter. So you can see I am using only number. Okay, then distance. Okay, distance. For example, 5 meter. Okay, 5 meter, 20 kilometer. Okay, then distance. Time. These are the scalar quantities, because these all quantities can be denoted with the help of numbers only. They don't have any particular direction. So those quantities which are denoted only by the magnitude, that means number, not by direction, then that quantities are known as scalar quantity. The quantities, when any quantity is denoted by magnitude, not by direction. See, you can see these quantities do not have direction. For example, I say 2 liters of milk, but is the 2 liters have any direction? If I say 2 liters of milk, so I am not using direction. I am not saying that 2 liters of milk in east, 5 liters of milk in west. I am not using the direction. So when any quantity is denoted with the help of magnitude only, okay, then that quantity is known as scalar quantity. We are not using direction. In scalar quantity, we are not using the direction. Clear? So these quantities are the scalar quantity. Then next quantity is vector quantity. Next quantity is vector quantity, third. So, if any quantity is denoted with the help of magnitude as well as direction, then that quantity is known as vector quantity. If any quantity is denoted with the help of magnitude as well as direction, then that quantity is known as vector quantity. So when any quantity is denoted with magnitude as well as direction. Okay, when any quantity is denoted with the help of magnitude as well as direction, then that quantity is known as vector quantity. The example of vector quantities we can take weight, okay, acceleration, velocity, displacement, etc. Okay. See, these quantities can be denoted with the help of number, or they are denoting with the help of number as well as direction. Okay. Acceleration. Okay. Acceleration. For example, 20 meter per second. Acceleration. If I am using the word acceleration, then I will say 20 meter per second in east. Okay. 30 meter per second in west. Okay. Velocity. Velocity is 2 meter. Okay, 2 meter in east, 3 meter in west. Displacement. Okay, displacement means change of position or the distance between the initial point and final point. The distance between the initial point and final point is known as displacement. Okay, if I say an object displaces from its mean position to 10 meter. Okay, 10 meter. So I'll say 10 meter. In which direction? East. I have to use the direction. in this quantity I have to use the magnitude, that is number as well as direction. Therefore, these quantities are known as vector quantity. These quantities are known as vector quantities. So we can understand the quantities which are denoted only by the numbers or magnitude, then that quantities are known as scalar quantities. The quantities which are denoted with the help of number as well as direction, then that quantities are known as vector quantities. Clear? Then next concept is, or next factor is distance. Now what is distance? Okay. First we will write the definition of distance, then we will understand distance. The total pathway covered by an object is known as distance. Okay. The total pathway covered by any object is known as distance. For example, if I have object A, okay, if I have object A is moved to position B, to C, to D and to A again. Okay. For example, if I have object and I have 4 positions. For example, if I have any object and that object is moved from A to B, B to C, C to D and D to A. For example, object covers or object travels a distance 2 km from A to B, 3 km from B to C, 1 km from C to D and 4 km from D to A. Okay, if any object covers a distance 2 km from A to B, then B to C 3 km, C to D 1 km and D to A again 4 km. Then the question is, calculate the distance traveled by an object. Okay, calculate the distance traveled by the object. So according to the definition, what we can say, the total pathway covered by an object, is known as distance. Okay, the total pathway covered by an object is known as distance. So here we will solve answer. So distance is equal to the pathway covered, the total pathway covered by an object. First object moves from A to B, so I will write A to B. Then object travels from B to C, then from C to D and from D to A. Okay, object travels from A to B, B to C and C to D and D to A. So what is the value of A to B? 2 km. B to C object traveled 3 km. C to D object traveled 1 km and D to A object traveled 4 km. Then the total distance covered, we can write 2 plus 3 5 plus 1 6 plus 4 10 km. Okay, 10 km. In examination they can give you any diagram and the distance will be written on the diagram, and if they ask you what is the total distance, then you have to calculate the full pathway, the distance traveled by object, okay, in full pathway. An object moved from A to B, B to C, C to D and D to A. So we'll add, simply we'll add the distances and we can write the distance traveled by an object is 10 km. Okay. So again we can understand distance, the total pathway covered by an object. The total pathway covered by an object is known as distance. Okay. Next we can write distance is scalar quantity. Distance is scalar quantity. Why we can say distance is a scalar quantity? As we have learned in previous, distance is scalar quantity. Why? Distance don't have any direction. If I say I have traveled 10 km distance from school to my house, okay, then I will not mention the direction. Okay, this is sufficient. The distance between my school and my house is 10 km. It doesn't require any direction. So distance is scalar quantity. Distance is scalar quantity. Then we can write the SI unit of distance. The SI unit of distance is meter. Okay, the distance is denoted in terms of kilometer or meter, but we are writing the SI unit of distance is in meter. We can convert the meter into kilometer or centimeter, but we are writing the SI unit of distance is in meter. Clear? The next concept is displacement. So the next concept is displacement, and the concept displacement will study in next lecture. Okay, thank you.